All right, guys, can we finish this unit now? Can we finish this year? All right, so the 6 in the front is called a vertical stretch by a factor of 6, or a vertical stretch of 6. The numbers in the front stay the same, okay? And it's a vertical stretch, so it's going to impact my y values. I got to look at the original sine y values and change those. The original sine y values are 0, 1, 0, -1, 0, if you're going around the unit circle, okay? So I am multiplying those by 6. And I get 0, 6, 0, -6, 0. The zeros stay zeros there. That part's, oh, am I frozen? Thanks so much. Okay, now I didn't know that. All right, there we go. All right. Vertical stretch of 6, 0, 6, 0, -6, 0. We okay with that? And the amplitude would be half of the height of the graph. So the graph goes from -6 to +6, which is 12. Half of that is 6. Or it's just the number in front. All right, so the amplitude here is 6. All right. Now, yesterday we talked about what the plus pi does. We call that a phase shift of negative pi. And the reason it's negative pi is plus pi makes the graph go left, which moves it into the negative direction. It moves it by minus pi. So I'm subtracting pi from all of the original sine x values. So the original sine x values are 0, pi over 2, pi, 3 pi over 2, and 2 pi. And what I'm showing you here is me subtracting pi. It becomes difficult to do with the fraction ones. So you can see in orange, I put 2's in the top and bottom to make common denominators. That makes the subtraction a little bit easier. So 0 minus pi, that first one's going to be negative pi. But for the second one, I made common denominators. So you'll see I get negative pi over 2 here. Pi minus pi is pretty easy. But for 3 pi over 2, the common denominator made it a little easier. And then 2 pi minus pi is pi. The period is how long it takes to get from start to finish. So the distance of time between negative pi and positive pi. So pi minus negative pi is like pi plus pi. It's 2 pi. The speed of this graph didn't change because the speed of the graph is coming from the slope, and there is no slope change here, okay? And so the period is the same as the original period, and the original period is 2 pi. Anybody have questions on this first one? All right, let's look at the second one. The second one has a negative in front. That negative is called a reflection. And the reflection will impact the y values because it's going to take what once was at 1 and flip it down to -1. So the values are changing slightly. I'm multiplying all the y values by -1. All right? And then there is a phase shift here, or sorry, there's an amplitude here of just 1. We don't call the amplitude -1 because amplitude is height, and heights can't be negative, right? But from the lowest point -1 to the highest point +1, that's 2 units, and amplitude, we just cut that in half. Or we look at the number in front. When there's no number in front, we put a 1. The amplitude is 1. All right, now we call this a phase shift, but we call it a phase shift of plus 3 pi over 2 or positive 3 pi over 2 because it's going to go to the right. All right, so what you're going to see is me taking the original cosine values and adding 3 pi over 2 to each of them. And for some of them, I had to make common denominators. Okay, so for the pi and the 2 pi, I made common denominators. All right, so I got 3 pi over 2. For this one here, I got 4 pi over 2, but that's just 2 pi because 4 over 2. For this one, 3 plus 2 is 5 pi over 2. For this one, I got 6 pi over 2, but that's 3 pi. And when I put the 2's here, this top actually becomes 2 times 2 pi, so that's 4 pi plus 3, so 7 pi over 2. And the period is the start to the finish, right? So 7 minus 3 is 4 pi over 2, which is still just 2 pi. Because the speed of the graph didn't change, just the location of it did. The runner's still running at the same rate, he just got a head start, okay? So the speed is the same, the period's the same. Anybody have questions on that one? All right, and then the last one had a 1/4, and that's called a compress, because now I'm making the graph a fourth of its original height. So the vertical values are going to change by 1/4. And so since the number in front is 1/4, the amplitude is 1/4. The minus 2 pi is a phase shift, but it's going to go plus 2 pi. It's moving everything to the right 2 pi. So I'm going to take the x values and I'm adding 2 pi to all of them. You can see for the pi over 2 and the 3 pi over 2, I added 2's in orange to make those common denominators. That makes the math a little easier. Because like the 0 plus 2 pi and the pi plus 2 pi and the 2 pi plus 2 pi, those are pretty easy and straightforward. The fractions are a little more difficult. The distance from start to finish, from 2 pi to 4 pi, is still just 2 pi. So if I subtract the start from the finish, I'm still getting the same period of 2 pi. Those are must-knows. You have to be able to do those problems. Remember, we have 2 practice days between next week before your quiz. Everybody will have Tuesday as a practice day, and then seniors will have Wednesday, and juniors will have Thursday, and then your quiz is Friday. All right? This is a cool if you know it, but it's an extra credit type of question. Okay? So just in case anybody did it. This has a vertical shift, a horizontal stretch, and a phase shift. So I have the work kind of off to the side because I had to multiply and add or subtract. So it took a little bit longer to do. Yep.
When doing this, do you do the horizontal stretch first, then just add the phase shift after?
Yes, because order of operations says we got to multiply before we add or subtract. So you're going to do the horizontal shift, stretch or shrink first, and then the phase shift.
And this is only extra credit.
Just extra credit. Yep. You won't have to do a horizontal stretch shrink with a phase shift. You won't have to do a double X change on your test.
This is what this, like the extra credit question will look like on the quiz.
Yep. Just like that. This is the hardest it's going to get. Today I think you'll find pretty easy because we're going to move the graph, but instead of moving it left and right, we're going to move it up and down, which affects the y values, and the y values are easy to change. Look at them. Like I can change a 7 moving it up pretty easy. So we're going to be adding and subtracting to the y values, which is a lot easier than doing x. All right, so today should be pretty light. So we're going to talk about vertical and vertical shift of the sine and cosine curves. We're going to do this in our toolkits. So toolkit, I think it's page 6 has this, but my pages are usually wrong. So check page 6 of your toolkit, see if that's what this is. So we've got A in the front. A is a vertical stretch or shrink value. It makes the graph taller or shorter. B is a horizontal stretch or shrink. It makes the graph faster or slower. C is a phase shift. It moves the graph left and right. D is a vertical shift. It moves the graph up and down. Okay? So anything that's vertical, the way I think about it is anything that's a vertical change makes sense. Anything that's a horizontal change is opposite of what your brain wants it to be. So when you see that B is 2, you want it to be a stretch, but it's actually a compress. When you see that B is 1/2, you want it to be a compress, but it's actually a stretch. When you see that C is minus pi, it's actually plus pi, right? So anything that affects the x values work opposite, but anything that affects the y values makes sense. So a plus D goes up, and that makes sense. And a minus D goes down, and that makes sense. The C and the B are opposite of what your brain would want them to be. All right, so where it says plus C, we're going to see up D units versus minus D would be down D units. Since vertical shift is up and down, this is going to impact the y values of the sine and the cosine curves. You have this one. Okay, and then I'm adding in this special note. You don't have to if you don't want to, but amplitude is the overall height of the graph. And since a vertical shift is picking up the entire graph and moving it, the height isn't going to change. So like, it'd be like me picking you up off the ground, right? You're still the same height. You're just up a little higher, okay? So the height doesn't change, which means the amplitude isn't affected by the d value, okay? So d does not affect amplitude. It also doesn't affect period, but period is a horizontal change, so I think that part's obvious. Your amplitude, think of like amplitude starts with A. Your amplitude is always the A value. It has nothing to do with the D value. Okay? So D does not affect the amplitude. So let's look at some examples with vertical and vertical up and down shifts. So this one is sine of x plus 5. The plus 5 is on the outside of the parentheses. If it was on the inside of the parentheses, it's with x. And that's a horizontal shift. That's a phase change, okay? The fact that it's on the outside puts it in this D spot. And a plus 5 is going to make it move up 5. So this graph is going to move up 5 units. You don't even have to write units. If you just want to write up 5, that's fine, all right? And up and down is a y change. So I'm going to change the y values. The original sine y values, that original critical 5 points, is 0, 1, 0, -1, 0. And what I want to do is move those up 5. So what do you think I do to them? Add 5. Okay, so all I'm going to do is add 5 to each of these values. So the new y value starts at 5. 1 plus 5 is 6. 0 plus 5 is 5. -1 plus 5 is 4. 0 plus 5 is 5. So sometimes the idea of the amplitude could get lost in translation here, and you could say, like, I think the amplitude's 6, because the biggest value that I'm seeing is 6. But the amplitude is the height divided by 2. So if I'm going from 4 to 6, that's 2 units divided by 2 is 1. The amplitude is still 1. The amplitude is the A value. The A value is the leading coefficient, and if there's not one there, you put a 1. The amplitude is 1. Okay, so the amplitude isn't necessarily coming from the values of the table. It's coming from the equation. All right. Now, in terms of my x values, there's no horizontal change here. I would need like a slope, so I'd need like a number in front of the parentheses or something inside with the x to move the x's around. And I don't have either of those here, which means I'm just going to keep the original sine x values. 0, pi over 2, pi, 3 pi over 2, 2 pi. Just the corner points of our unit circle. Right, like the 0, 90, 180, 270, 360, but in radians. And my period is the speed that the graph takes to get from start to finish. So from 0 to 2 pi is 2 pi. First x value minus last x value minus first x value. So that's 2 pi. Right? Let's look at the next example. Cosine of x minus 2. The minus 2 is at the very end. It's not in the parentheses with the x. Inside is a phase change. Outside is an up, down. This is minus. So this is going to be a down 2 units. Or just down 2. Now this is a cosine. So the 5 critical points are different. Not different. The 5 critical points are in a different order, I should say, right? Cosine is 1, 0, negative 1, 0, 1, right? So the y values are coming from the original sine and cosine y values, which are the same numbers in a different order. Okay? So I'm going to shift these down 2, so I'm going to subtract 2 from each of them. So 1 minus 2 is negative 1. 0 minus 2 is negative 2. Negative 1 minus 2 is negative 3. 0 minus 2 is negative 2. 1 minus 2 is negative 1. The lowest point, negative 3, to the highest point, negative 1, is 2 units apart. Divided by 2 gives me my amplitude of 1. Okay? Or A is amplitude. A is the leading coefficient, and if there isn't one, then the amplitude is 1. The number in front. This only has a down-up change. It's got nothing left-right. It's got nothing horizontal. The x values are not impacted. So I'm still using the original x values. Those are unchanged. And so to get from the end to the beginning, or vice versa, 2 pi minus 0, the period, the speed of this graph is 2 pi long. So both of those examples were just the d value changing. The next example that we do is going to have another letter change too. So you can see that you can change the d and other things as well. All right, so example 14. We got a few things happening here, okay? So the negative in the very front, that's called a reflection. So there is a it never reflects over y. It always reflects over x, okay? So the negative in front does that. The 2 is called a vertical. When the number in front is bigger than 1, we call it a stretch. Of 2. The 3 is the speed of the graph. It's a 3x, right? So if a regular linear graph is x, the 3x is steeper. It moves at a quicker rate. So this graph is going to move at a quicker rate. And if the curve moves at a quicker rate, the period that it takes to finish the race shortens, right? It gets done quicker. So shortening it is called a shrink or a compress. So even though this is a whole number like the 2 is, this one is called a compress and that one's called a stretch. So this is a horizontal compress. Like I said earlier, the x value ones do the opposite thing that you would think they do, okay? So a horizontal compress, and anytime you have a compress, you need a fraction. So I'm doing the reciprocal of 3. And I'm going to call it a horizontal compress of 1/3. And then the last thing is the +1. And that's going to make it go up 1 unit. And that's this one. I think the hardest ones are the horizontal stretch and compress and the phase change, the x value changes. All right, so let's think about what we're working with. I'm going to start with just the original sine stuff. I'm going to write it on the outside. So sine in its original form has 0 for an x, pi over 2, pi, 3 pi over 2, and 2 pi. And I'm putting them on the outside because they're not the new answers, right? And sine in its original form for y starts at 0, 1, 0, -1, and 0. And I'm going to change them, right? So the first change that I'm doing is the reflected over the x-axis and the vertical stretch of -2. A vertical stretch is going to make it 2 times taller. So it's going to double all of the values. So I am multiplying all the y values because it's vertical, it's y, by -2. So that's what the reflected in the vertical stretch does. The horizontal compress shrinks all of the values. It divides them by 3, or it multiplies them by 1/3. And because it's horizontal, I'm doing that to the y values. And the up 1 unit is vertical. So I'm going up and down. That impacts the y values. So I'm going to add 1. In order of operations, the multiplication has to happen before the addition. So the red has to happen before the orange in order of operations. I'm not going to add 1, then multiply by 2. I got to multiply first, then add. All right? So doing this math will get me my final table. It takes care of everything. I've got the reflection with the negative. I've got the vertical stretch with the ×2. I've got the up 1 with the +1. And I've got the horizontal compress with the 1/3. And that's horizontal, so it's x values. All right? So let's start at the top here. 0 times 1/3 is 0. Pi over 2 times 1/3. I'm going to do the top, pi times 1, and the bottom, 2 times 3. All right, for this next part, I need common denominators here. So I'm going to do a 3 and a 3 here. Oh, no, I don't. I don't need common denominators, so I'm not adding, nor me. I'm just going to put a denominator of 1 so that I can do top times top, bottom times bottom. Pi times 1 is pi, and 1 times 3 is 3. So that's pi over 3. 3 pi times 1 is 3 pi, and 2 times 3 is 6. But what's 3/6? Pi over 2. So I'm going to erase that and just change it to pi over 2. It reduces. And then I'm going to give this a denominator of 1. 2 pi times 1 is 2 pi. 1 times 3 is 3. All of these values are 1/3 of what they originally were. Which means what once took 2 pi to finish now takes less time. It takes 1/3 of the time. So to get from start to finish, it takes 2 pi over 3 units. So the period is 2 pi over 3. Finish minus start, the length of the time to get from the beginning to the end. All right, down here if I do 0 times -2, that's 0, plus 1 is 1. And you can just type this in your calculator too. 1 times -2 plus 1. It'll do it in order anyway. Like you don't need anything special with parentheses. But 1 times -2 is -2. -2 plus 1 is -1. 0 times -2 is 0. 0 plus 1 is 1. -1 times -2 is +2. And +2 plus 1 is 3. 0 times -2 is 0. 0 plus 1 is 1. The lowest point of the graph is -1. The highest point of the graph is 3. That distance is 4 units. Amplitude is cutting that distance in half. The amplitude is 2. Another way to look at amplitude is it's the A value. It's the leading coefficient of 2. Amplitude is height, and so height isn't negative. I'm not going to put the negative with the amplitude. It's just the 2. In my opinion, on things that I'm like actually going to grade you on your test, that's the hardest problem you'll see.
Isn't it like the same thing as like the extra credit that you said is on the other side?
The extra credit would have a plus minus inside with the x2. That's harder. Because now you're doing 2 things to the x's. Doing 2 things to the y isn't hard because the y is whole numbers. The x's have fractions, so you're doing a harder thing. So if it has a phase change and a horizontal change, that's what the extra credit would be. This I think you should be able to do. This is like something you have to be able to do.
Is the y's, like for this, is it always gonna be whole numbers then? You're saying.
It could be fractions, but the thing is you can type them into your calculator. You can't type pi into your calculator because your calculator is going to spit out a decimal that you can't math enter. But if it's 1/4 without pi, you can just type it in your calculator. I think I might do one that has that, but even if the bottom had fractions, it would be easy. It's the top that's hard because of that pi. All right, so let's look at, do I have another one on here? Yeah, so this one has the fraction in front right here, so we'll do this one. But again, this is one that I'm expecting you to be able to do on your test because you'll see there's only one horizontal change here, there's not two. Okay, so the 1/2 in the front is called a vertical compress. It's going to make the graph half of its original height. All the values will cut in half. So it's a vertical compress of 1/2. Now, there's no slope here. There's no b value. The b value is the one after the cosine, but in front of the x, like the number being multiplied by x. I don't have that, meaning that the speed of the graph is going to stay the same. It's going to take 2 pi units. Whether that's the starting value or not, it's going to take 2 pi units. The speed doesn't change. There's no horizontal stretch or compress. The +3 is called a phase change. So we call this a phase change or a phase shift of, and the +3 pi over 2 is going to make the graph go left. So I actually do a -3 pi over 2 for the phase change. And then the -4 is going to make the graph go down 4. This is the cosine graph. So I want to go with the original cosine table over here. So the x values are 0, pi over 2, pi, 3 pi over 2, and 2 pi. The y values are the same, but they're in a different pattern. It's 1, 0, -1, 0, 1. Do you have to memorize that? Sure you can, but you already have memorized that. When you memorize the unit circle, you memorize those values. Cosine is the x values of the unit circle, and you already have those memorized. So I'm just putting them into the table, right? So vertical compress of 1/2, that's vertical. It's going to impact the y values by cutting them in half. I'm going to multiply these all by 1/2. Phase change is a left shift. Because it's left and right, that's an x value impact. So I'm going to subtract 3 pi over 2 from all the x values. And down 2 is an up and down change. So that's y values, and down is a minus. Now I got to do the math. Now, if you don't want to do math with fractions in your head, the bottom ones you can do in your calculator, the top ones you can't, and I'm going to show you why. So if I type 1 times 1/2 minus 4 into my calculator, it'll do that, right? And it'll give me something that if I wanted to make it a fraction, I can do that. All right, so you can type this into your calculator. What I can't type into my calculator is the top, and I'll show you why after we're done the bottom. So here's the first one of the bottom. It's going to be -3.5 or -7 over 2. I don't care which one you write. So that one is going to be the same as the last one. I'm doing the same math, so I'm just going to filter that in there too, so I don't have to do it twice. Well, 0 times 1/2 is 0, and then -4. I don't even have to type that one in my calculator. That's gonna be a minus 4. And maybe I wanna type the next one in. So I'm gonna do -1 times 1/2 minus 2, or minus 4. I can write it like that, or I can write it like this. The amplitude is the A value. The A value is the leading coefficient, and that's 1/2. I can't do the top math in my calculator. And here's why. If I try to type that into my calculator, 0 minus 3 pi over 2. I get this, and I can't do this. And I can't write those decimals all in my table. There's not even enough space to do that if I wanted to. And then if you round it, it's not technically right, okay? So the x values are harder because of the pi. You can't put them in your calculator. So this is where we're gonna work on, since we're adding and subtracting, to add and subtract fractions, you need common denominators, right? Multiplying, you can multiply anything, but adding and subtracting, you need common denominators. So this one's easy because I'm just subtracting from 0. And the next one's easier too because they have common denominators already. It's like 1 minus 3. So -2 pi, and then when you add and subtract fractions, the denominator stays the same. And then what happens here is the 2's cancel out, and it's just -pi. I'm going to skip over the middle one and go to this one. This is pretty easy too. 3 pi over 2 minus 3 pi over 2 is 0, right? So I can filter that one in pretty quickly. The other ones are a little bit harder. If I'm doing pi minus 3 pi over 2, I need a common denominator when I add and subtract fractions. So I gotta give this a 2, and if I do that to the bottom, I've gotta do that to the top as well. So this becomes 2 minus 3, or -1 pi, and then I keep the denominator the same. If I'm doing 2 pi minus 3 pi over 2, I need a common denominator, so I'll give this a 2, which means I've got to give this a 2. So this ultimately becomes 4 pi minus 3. So 4 minus 3 is 1 pi, and then the denominator stays the same. The speed of this graph did not change. It did not stretch or shrink. There is no slope. There is no b value. The b value is the one that affects the period. The period is like the length it takes to finish a curve. Period would be, in this case, pi over 2 minus -3 pi over 2, right? Finish minus start, but that double negative there just changes to a plus. So I end up with 4 pi over 2, which is just 2 pi. The period will not change from 2 pi unless there is a horizontal stretch or compress. And if there is a horizontal stretch or compress, the period will change by multiplying 2 pi by whatever that factor is. If the factor is 1/3, it's 2 pi times 1/3. If the factor is 5, it's 2 pi times 5. So the period only changes if there's a b value. You need a number here for the period to change. All right, so again, in my opinion, a problem like this or this is as hard as it would get on your test, where you've got to change the x value one time and the y value twice, whether it be the x value as a horizontal stretch or compress or as a phase change, okay? Doing 2 x changes and 2 y changes, which would be everything we did, would be an extra credit question. If you want to do practice, There's extra practice on page 6, and there's a key on Canvas, okay? If you don't wanna do practice, we have 2 days of practice next week. So next week, we're off tomorrow, we're off Monday. Tuesday, we're all here, we're gonna do a practice day Tuesday. It'll be more of like a check-in practice day. And then Wednesday, Thursday will be like an on your own practice day, and then Friday will be your quiz, all right? If you wanna do practice, that key's posted on Canvas.
What was the test about? 'Cause they're on the website.
So there was 2, there was 3 actually. They were all trig. So we had a unit